15, 1.3, 1.1, 0.9, 0.4.
Make sure once you've got your numbers in here that you add units
Okay.
to the things.
Average luminosity.
How do you spell that?
LUMINOSITY.
Yes, she was like
I love that about her. No matter who it is.
1, comma,
Okay.
no, 1400.
Six.
I know I am.
1.2.
So invitations will be delivered tomorrow.
0.4.
Remember that if you're bringing a guest that does not attend school here, they
0.
need to have a valid ID.
0.004.
Verify that they're real.
Average lifetime.
Also, the age of the and if you park in the parking garage, if you find other parking, just be sure that if you're parking with money, you bring money to pay. Thank you. Have a great day.
4 zeros, point 4 zeros, 46.
So I just read this article and then I answer.
Yeah, you just read the article and answer the questions. Why is that okay?
I think so, because remember she said everything's in terms of the sun. Like the astronomical units is the length. Answer.
Well, no, I'm just wondering. She said put units on for our tables, but do we just put the sum at the sun equals 1 per unit, or what exactly are we going with?
I think so, because remember she said everything's in terms of the sun.
Okay.
Like the astronomical units is the length, the average length from the Earth to the sun. This is the average mass of the sun. But what's the mass measured in? Besides the sun. I don't think it tells us specifically here, but
In our journal.
when you actually look at the other table, okay, luminosity is just in terms of the sun. Magnitude, it doesn't give us units on these. I'm not sure. I'd check the internet and see what she wants.
All right, thank you. Did she leave already?
No.
The units, what are they? Like, it'll say.
The way they said it. So we just figure that out later. Okay. Now we workshop on what those units are.
Okay.
Okay, so I'll be done.
I'll do that for now, and then I'll show you.
My internet's not working.
I'm going to show you APA citations in the back out of right after your
Okay, if you want to title this one, it's Circle Equations. What's special about the radius of a circle?
360 dollars.
The radius of a circle?
Okay, it rotates around 360 degrees.
It's half the diameter.
Okay, it's half the diameter. What else? There's one thing very special that I'm looking for about the radius, or when you're comparing various radii. What am I looking for? So if I have a circle from point A to point B, if that point B is on the circle and I have some other point over here, point D, what's special about those radii?
They're the same length.
Okay, they're going to be the same length. Okay? Now, if I have AB set at one length, okay, so you'll notice in red AB is staying at 6. Those other lengths are changing, right? Okay, the longer CA is, the shorter CB is. And same thing, vice versa. Okay, so we've got a circle here. So this point B has an x value and a y value. Now, to find how would this x and y relate if this circle was centered around 0, 0? If this was centered around 0, 0, then what would this length be? Okay, you're counting them, which this one would be 4. But this length would be x units long because it's the x value of this point. Does that make sense?
Yeah.
Okay. How tall would this be if this was at 0, 0 and it had this point xy? It's going to be y units tall. Okay, is everybody with me so far? Okay, so then how does our radius relate to those? It's x plus y? Do you guys agree with that?
Yeah, that makes sense.
What's this?
Triangle.
It's a triangle. Is there anything special about this triangle?
Right.
It's a right triangle. What do you know about right triangles?
A squared plus b squared equals c squared.
Okay, so what would our a be in this situation?
X.
Okay, so it's going to be x squared. What else?
Y squared
Okay,
equals R squared.
okay. That would be if it's centered around 0, 0. Whoa.
Oh, can we write that down?
Okay? But we are not centered at 0, 0. So we have to adjust it. Does anybody remember what our horizontal shift is called? Think about when we did the vertex form of quadratics. Okay, Jonesy says H. Does that sound familiar?
Yes.
Okay, H stands for horizontal. So this is going to be our horizontal shift. Does anybody remember what goes with H? Okay. So we've got H and K. So we're going to shift these over. So what we're going to do is, instead of adding them, it's backwards. You're going to subtract them. So x minus h squared plus y minus k squared equals our radius squared.
Okay, so whenever it's not centered at 0, 0, that's the equation you use?
Well, this is the equation, but if it's centered at 0, 0, h is 0 and k is 0.
Okay.
So they just go away.
Okay.
Does that make sense? So in this particular case, what's our equation of this one?
8.
Okay, where's the 8 coming from?
The x.
Okay, so you count over 8 spaces. This one's a kind of bad example. The k is also 8.
Okay.
Okay, what's our radius?
6.
How'd you get that?
Oh.
Well, from the center, you can just count our radius because it's all on the same line and you can see them. So 1, 2, 3, 4, 5, 6. So our radius is 6 there. So for this particular line, or sorry, circle, our equation is going to be x minus 8 squared plus y minus 8 squared equals 6 squared. Okay? Does anybody have questions so far?
So we solve that.
Well, this is the equation. This gives us all the points.
Y is 8, and then
But
y is
Conrad brings up a point. Can we solve for anything? If you know the x value, so for example, if I'm at x equals 12, I can solve for the two y values. If I know y is at a certain value, I can solve for the x values from this one. Okay? Can you graph this in your calculator? Just like this?
No, you gotta put y on the other side.
Okay, so we need to solve for y if we want to graph this in our calculator. Okay? So this is one form of the equation. I'm going to write that down.
What's that equation for, though? Just write that.
This is generally what you'll see as the circle equation, because this is all the points. The next one that we're going to do, you'll see, because we have a square root, we can only graph half of it at a time. And you'll see.
Did we already do that before, though?
Yes, we have done this before, but it's been a while. So we're going to refresh you, just so you remember this part, and then we'll get into the other ellipses later. Okay? So, when we're solving for y, instead of doing PEMDAS, which you would do if you're just simplifying, we're going to do reverse PEMDAS. Okay? Do we have any add or subtract on the y side, which we're solving for? Where?
You're adding the x minus h squared plus y minus k squared, and then you're subtracting the y from the k squared.
Okay, so do we count this as an add or a subtract? It's inside the parentheses. So because it's inside the parentheses, we ignore that. But this one, yes. We'll take care of that one. And I'm going to write this. What sign is this one?
It's positive.
It's positive because we don't see a negative. So you can do the opposite. You can think of it as y minus k squared plus x minus h squared because you have to do the opposite to get rid of this. Okay, who has questions so far? Yes. So the reason that I put this plus out here is because we have to do the opposite of whatever operation is happening there. And since I don't see a sign, it's positive. I would see a negative sign if it was negative, right? Okay, so I put this positive here just to reassure myself that it's positive, so I know I do the opposite, and I'm going to subtract that from both sides. Okay? To get y by itself, I'm clearing everything off of the y side. This is one big unit right now, and this is one big chunk right here. So we're going to take this whole chunk off because it's all together. Is that the only part you were confused about? Okay. Okay, so when I subtract that from both sides, is everybody okay with that so far? Okay, so what should I do next?
Square root.
Why? Okay, so on this side, do we have any add or subtract? No, because it's inside the parentheses. Do we have any multiply or divide? Okay, so the next thing is exponent. Do we have an exponent? It's squared, so it's raised to the second power. So the opposite of squaring. So just like Castro was saying, we take the square root of both sides. Okay, here's the thing. When you're taking the square root, it could be positive or it could be negative. Okay? The reason I'm not writing it on this side is because you're taking the square root of just one thing squared. It's going to get rid of that squared. When you squared it, this one unit right here is going to be positive. Because a negative times a negative is positive, and a positive times a positive is positive. Over here, you have something squared minus something. So you could get a negative on this side. Okay? So that's why there's a plus minus on this side. Does that make sense? Okay, so you take the square root and it gets rid of that. So the good thing is, after we solve this, you won't have to go through these steps. You'll just have the two equations. Okay? What's next? Yeah, we don't even really need these parentheses right now. So it's y minus k, so we'll do the opposite, and we're going to add k to both sides. And then you get y equals, I'm going to put it in front, because when you guys put it on the back end, sometimes you accidentally put it under the radical, and then you don't get the equations that you want.
I said y equals something in the equation.
Okay. Okay, questions? Okay, so those are our two equations. We're pretty much usually going to use this one, just because it's easier for us to graph and things like that. What does the K stand for?
Why?
X.
Which Y?
Okay, starts
The K stands for the Y value, yes, but it stands for the Y value of our center of our circle. Okay? What does the R stand for? And what does the H stand for? The X value of our center. Okay? So we're going to find our center, and that gives us our H and our K. We're going to find out what our radius is, and that gives us our radius. And that's all we need to do our equation. Okay, let's try an example. Find the equation of this one. Use this version. Write it down, and then we'll check it together. Okay, let's go ahead and start on this one. So what's our center of our circle?
2, 3.
Okay, so we've got -2, 3. So -2 and +3. All right, what's our radius? Five? Is that right? Okay, so let's start writing. Y equals what?
3. Plus minus.
Plus squared.
Okay, so you can either write 5 squared or you can just write 25. Either of them's fine.
Minus X.
Parentheses, X.
Plus 2.
Why is it plus?
Negative.
Because our X value is negative, so X minus a -2 means X plus 2. Okay? Questions? Okay. Yes.
Where do you get the 25 from?
25. Where does that come from? It's our radius squared, which is 5. 5 squared is 25. You can either write 25 or 5 squared. Either of them is fine. You'll see it both ways, especially when I check and see if you know what you're doing. Okay. Other questions on this one? Okay. Try this next one. Okay, who's having a hard time getting started on this one? What's this point? Okay, why am I focusing on those 2 points? If I connect them with a segment, what's important about that? It's what?
Diameter.
It's a diameter. How do I know that? Because I can look at the curvature and see this is where it's the largest distance. Okay, it just happens to be on some points that I can tell. And why is that important?
Because it'll help us find our radius.
It'll help us find what?
Our radius.
Okay, so that'll help us find our radius, and that'll help us find our center, and then we'll be able to do our equation. So with that much, do you have enough to get started, or do you need more help? Okay, what's the length of this? How do you get that? So you're going to do 1 minus the other, so 8 minus -3 equals 11. And that's our diameter. But we want the radius, so we do what?
Is it alright if you put 6 or have to be 5?
Well, it's not 6. If you say that it's a radius of 6, then that's going to give you a different equation. So that's another thing. You'll want to be as accurate as possible. You're not going to round things. In the homework, I'll tell you to round to the 100th or 1,000th. What did I tell you to round to? I think I told you thousandths. But don't round in general when you're doing your equations. It'll be off. So do you have enough, or do you need more help?
No, I need help.
Okay. So our radius is 5.5. How do I find the center if I know that my radius is 5.5? I can either add to this x value, 5.5, or I can subtract from this value, 5.5. Because my center is between these two x values, right? Okay, so -3 plus 5.5 gives me 2.5. 8 minus 5.5 gives me 2.5. Okay? Now what? What's K stand for?
Why the center?
Y of the center. Okay, and our y value of the center is 0. So it's going to be y equals 0 plus or minus the square root.
5.5 squared.
Okay, we already solved for our radius, 5.5 squared.
Minus x minus 2.5.
And then our h is the x value of our center, which is 2.5. All right, questions about this one? Okay, I'm going to give you one more example. Then you're going to go back to working on getting stamps. And I've given you a short assignment. The assignment's going to be due tomorrow, but you have 5 stamps that are due today. How are you going to approach this? What's different about this one?
That the circle is a little bit over, like.
Okay, so you don't have an exact value that you can count on. What can you do to find the radius?
4. It's 4.
What's 4?
It's just a little bit over.
No, those are
It's
diagonals.
4, but it's something.
Can't you do
like
a
4
right
point.
Like 4.
So can we just go 1 squared plus 1 squared equals whatever?
Why 1 squared?
Because we can assume that we can find the diagonal of those each little grid
Can't you just do
and then just
diagonal
add that
theorem?
all the way. Am I right?
Connor, how are you doing this?
Exactly, thank you.
Do we solve that?
This is making me mad.
So Richard's been telling us for a while now. We can do Pythagorean theorem.
Alright, so 9 equals 18. 18.
Well, yes, you can find the length of this, but then you
No,
can
it's
see
16.
from this that you would have had 3 of those. So yes, you could take 1 square and figure out what that diagonal is, but then you'd have 3 of them. Okay, so we've got 3 squared is 9, plus 3 squared is 9, equals our radius squared. So what's our radius?
4.7.
What's our exact radius?
Anybody got a phone?
No, don't give me the approximate. That's a decimal value. That's approximately it. What's our exact radius? How do I get that?
Square root it. I'd say 4.24 on a good day.
Well, I would say you would be approximating. All right, so it's the square root of 18 is exactly our radius.
That's our radius.
And if you remember what we did before, actually we barely did this, but this is also 18 is 2 times 9. The square root of 9 is 3, so it's 3 square root of 2.
Oh.
So it's 3 hours.
We barely did this, so if you don't remember this, don't worry.
So for the equation, when we put 3 squared to the second
I thought you guessed.
You could.
I was like,
But
what?
you could also do square root of 18 squared, but what's the square root of 18 squared?
3 to the second power squared, or 3 square root 2 squared.
Okay, 1 second. Let's write the equation that we have so far. So we have y equals what?
E- 3.
What's our k?
-3.
What does K represent?
The y value
Of?
the center.
Okay, so what's that?
-3.
And then 5.
Okay. And our radius is? Or the square root of 18. Square root of 18 squared is what?
Huh?
What's the square root of 18 squared?
Let's go with 3 to the square root.
A square root of any number, and then you square that, it just takes the square root off.
Oh, wow.
Okay, and then we've got x minus, what's our h? Oh, oops, sorry.
Yeah, 5.
Okay, questions?
Homework on this?
Yes. So what you'll want to do is submit a blank form. It's not due until tomorrow. Work on your stamps first, and if you feel comfortable, then do this assignment.
Okay.
I've already had one person complete it, and it took him like 7 minutes, I think. So it's not that long of an assignment.
You're gonna copy paste this over.
If there's a star that's
Just make sure you have units.
Like AU? That's our units, right?
No, go look at your reference. The table had units. Not all of them are 80. Okay?
Okay.
Like you just talked about average lifetime. What was units again?
Billion.
Yeah. Billions of years. So you would put that in parentheses next. So make sure you include that in the copy paste.
Oh.
Don't take a picture of it. If you're doing this in Google Docs, you can always just copy it, cut and paste it. So that way if you have to change something in the report, you can.
I think it's G.
I'm about to see.
I think it's G.
What is supposed to be?
Because it's the 5 is positive.
Mm-hmm.
The 5 is positive. You square root your 4, which gives you 16. And then the equation is asking 5 and 4. So your 4 is going to be a K. Your K is going to be 4 and your H is going to be 5. You see it? This is your K and this is your H.
Mhm.
And then you have to square root your 4 because that's the radius.
Mhm.
So he said, you know how he said you can go ahead and
Square root it just when
square
it's. Oh yeah.
So 16 plus your H plus your K. We would just put our K in the front.
And then
Oh yeah, but he said that he wanted to do that because sometimes we'd put it where the something is, and he didn't want it. But yeah, that is your okay.
So you getting them?
Yeah.
this is good. Leave this. I like that this is in table form because at some point Banks is going to have to look for the radius of your star in order to correctly grade your diagrams. But I also want, because I'm giving you a written con grade, like below the table, explain why you chose those primers and why they're suitable for life. Like expand a little bit on your choices. And also for 1.5, show me how you calculated this lifespan and go ahead. You see how you have the equations here for your inner and outer radius of your habitable zone? Now that you've picked parameters, you can now calculate the inner and outer radius of the habitable zone for Toshiba. So go ahead and show how you did that. And I'll give you 1.5. And then you'll get this. So you're just, this is good, leave this, but expand a little more below. And then go ahead and show me how you're going to show me how you calculate lifespan.
Wait, so if we show the example of us calculating our lifespan here, then does that, or
Lifespan and your inner and outer radius of your habitable zone, that's 1.5 units.
wait, does that also take off for the 1.1 or for having an example? Because we showed the example here by using it to calculate this. Would that kind
this
of
lifetime. Yeah, I'll accept it. Yeah, we can do double one.
Okay, cool. Two versus one.
You're the one that set their start.
1.3. Too hot is too big. Too small is too cold. And like the sun, it's just right. So that's what I'm going to put. But how would we put that into words?
If the star is too big, it'll be too hot. If the star is too small,
But how would
it'll
we?
be too cold.
But how would we know if it was too big? Not based on the color, but based on its size.
Find a star that's too big and find out what its radius is. Say, this star is too big
But how would you know if it was too big?
because it's too hot.
How would you know if it was too hot?
Because if it's too hot for liquid water to be present on a planet, it's too hot. That's what we're going by. We know we need to survive, and we need water. And if a planet's too cold to have liquid water, if a planet it's too cold to have liquid water, too hot to have liquid water, we can't survive on that planet.
We can't, but maybe another form of life could.
But she's talking about but we don't know. Every form of life on Earth needs water. So we're going to assume that every form of life in the universe needs water.
Okay, but that's just assuming.
But that's what we look for when we're looking for a habitable planet. We're looking for a planet that has water or has the right temperatures for water.
But she said that it didn't have to be just our life. It could be any type of life.
But still, we're assuming that every life needs water because we have no other information to make a different assumption. So we're going to assume that no matter what, all life needs water.
Okay.
Everybody send one representative to the front. I need to find something that is going to impact everybody. I'm going to put something on the screen. Hold on. Okay, while I'm doing that, even though I'm not staring at you because I'm multitasking, listen to what I'm saying. There's a unit issue that we've uncovered just from the references we've given you. There's two lengths that you're giving us that are important for your graph of your solar system.
Sorry.
One of them is the radius of your star, okay? And the other one which kind of defines the size of your star, right? The other one are the radii for the inner and outer boundaries of your habitable zone. Unfortunately, the information are in two different units, and we can't have them in two different units if we're going to create a scale diagram. So we have to figure out how to resolve that. So we're going to go over that right now.
Just those.
So once you get to 1.4 and 1.5 of the rubric, and you're telling me the size of your star and the inner and outer radius of its habitable zones, I want all lengths are going to be will be in solar radii.
Solar will
So that means your radiuses are going to stay the same, but you're going to have to convert your inner and outer radius because the equations I gave you give you an AU, so you're going to have to convert it. Do you want me to practice this do you want me to show you how to do that conversion, or do you want to do it? Figure it out.
Can you do it this once?
Let's say, per se, you get an inner radius of 1.89A. Agree with it. Are we going to multiply by this number, or are we going to divide by this number?
Divide.
Yes.
Our radii that we have now, we're going to divide it by
Yes.
1.89.
Yeah. No, not 1.89. What's this number? That was from my example, but we're not going to go through it because you guys really know what you're doing. This is the conversion factor.
Okay.
Okay.